Live. Oh, not yet. There we are. We are live. Okay, today's date is 5/20/19. So what we're going to do today is talk about chords in circles. So a chord is just a line segment. That's all a chord is. It's a line segment in a circle. It's a line segment. So if I take a look at all three of my drawings, I've got two different chords here. I've got a chord AB and a chord DC. I've got a chord here and a chord here, and on these two, CD and AB are my chords. So we are talking about chords in circles, and the chords are the line segments in the circle. That's all that is, okay? Now there's some relationships. So one of the things that I do, I'm the teacher. So try and take all this math wording, this math symbolism, and try and put it in common sense. So here's what the first one says. Congruent chord theorem. So we're saying if AB, so if AB, yes, if AB is congruent to CD. So if this chord is equal to this chord, if this line segment is equal to this line segment, so if you have congruent chords, then the arcs that subtends them, the arcs, are also equal. Okay? So then, you can say that arc, the measure of arc AB is equal to the measure of arc CD. And that's it. If you've got two chords that are equal, then the arcs that subtend those arcs are also equal. Actually, it looks like it, doesn't it? Okay? So if the line segments are equal, the arcs are equal. Okay? Thumbs up. Does that make sense?
Are they congruent or equal?
Great question. Congruent means they have the exact same shape. Equal means equal measure. So it's a matter of, let's just say it's the same thing, okay? Right? Okay, ready for number two? Am I going too fast? Okay, number two. Perpendicular chord theorem. Now, first of all, let me draw it wrong so you can see it. You draw it incorrectly, okay? I've got a diameter, right? Let me draw this chord differently. See my green chord?
Indeed.
Is this little piece equal to this piece?
No.
Not at all.
No, it's all
The only way these two pieces could be equal is if this is perpendicular to 90 degrees. It's the only way. You guys agree? What if I drew it like this? Is this little piece here equal to that? No. The only way they could be equal is if this was at 90 degrees. So it's saying that if, so we have a diameter. Let's write that down. That we've got a diameter. So we have a diameter of EG. And it can also be a radius or a radius, right? I can. So if I have a diameter, and it has to be an if EG, that's my diameter, okay? If EG is this line right here. If it's perpendicular, okay, that's the little 90 degree symbol, right? If it's perpendicular to FH, or to my chord, okay? If it's perpendicular or 90 degrees, put my little box in there. If it is at 90 degrees, then it cuts it in half. Then it cuts it in half, right? So let me put another little point here. What's that point the book puts in there? They got H. Oh, let's see. What letter am I missing? Let's just put X here, okay? For that symbol here. Then we can say that Fx is congruent or equal to XH. Okay? So all we're saying is this. If these two lines, these two chords are perpendicular, it cuts in half. Does that make sense? If these two are at 90 degrees, it cuts in half. We saw that if I drew another picture, I drew it wrong, right? That's not equal to that. The only way that could be equal to that is if it stands straight up and down at 90. Does that make sense? A lot of geometry is common sense. They use a lot of words to say what seems already known. Yeah, Leon?
Oh, wait, that's one.
Okay. All right, now let's take a look at number three. So number three is a little bit weird because it talks about equidistance. So I want to show that CD is equal distance to AB. Okay, equal distance from the center. Okay, so how can I show that CD is equal distance? So the distance from here to here. So what we do is we draw a line straight to it at 90. Okay, at 90. Let's call this X. Okay, and then straight down 90. So if I do that, if I say, okay, think about this. I'm standing right here, and I want you to draw this line. Think of this like a playground, okay? So I'm standing right here to run that line. I would run straight to it, right? I wouldn't run to it this way, you watching? That'd be the long way. So that's the distance to this chord, the straight to it. That's the distance to that chord right there, okay? Now, if that's the case, then these two have to be equal. So if they're equal distance, if the chords are equal distance to the center, they are equal, okay? So if I can say that if CD and AB are equal distance, equidistance. Okay, if they're equal distance to the center, then they are congruent. So let me mark it. Okay, so I know that if it is equal distance, then this chord is equal to this chord. Okay, now this guy. Yep, I will slow down. Okay, so equal distance meaning from the center, from standing right here, the distance from here to this chord is equal to the distance from here to this chord, and those two chords equal. Say it again. The distance. This length here is equal to this length here. Equal distance. Equal distance. That's true, then that chord's got to be equal to that chord, okay? So a lot of geometry is just easy things, but they just use a lot of words and symbols to say things that you already know, okay? Abby, let me know when you're ready. Are you ready?
Yeah.
Okay, everybody got it? Okay, so let's turn the page and use these concepts on these problems, okay? So, if I take a look at example 1, and I want to find the measure of arc XY, okay? I want to find that arc right there, okay? In fact, I think I can find them all. Here's what I know. I know that this entire chord has to be equal to this entire chord, right? Because it says this piece is equal to this piece, and this piece is equal to this. So this from W, so I know this. I know that WY, this is what I know. WY is congruent to ZX. Has to be. I mean, because if that side's equal to that side, and that side's equal to that side, it makes both chords equal to each other. We can see, okay? Well, if that's the case, if I flip my page, it says if I've got equal chords, then the arcs are equal, right? If I have equal chords, and I have equal chords, and the arcs are equal. So this has got to be 110 degrees. That's it. Yes?
Then how is it possible that 110 plus 110 plus 60 plus 60 is 360?
Now, is this 60? This has got to be something else, doesn't it? Right?
Because those aren't equal chords there.
Right,
Wait.
right. They're not.
Oh, I see.
So what we can do, you tolerate. Let's go ahead and find that one. Chase, I like that idea. 360, if I go minus 110, minus another 110, minus 60, I should be able to find that chord right there. And I think it's 80. I'm pretty sure it's 80, but I'll do it real quickly. Chase, you always ask good questions. Minus 110, minus 110, minus 60, and I get an answer of about 80. Yeah, so that chord is actually 80. Okay, great question. Okay, now, thumbs up. Okay, let's look at example 2. All right, in example 2, it says find the radius. Well, I don't see a radius in here, so I'm going to draw it. It says find the radius, so let me highlight it, okay?
Wait, what about example 2?
Oh, I'm ahead of myself. Sorry. Example 2. I'm ahead of myself. Thank you. Find the value of x. Well, it's 90, isn't it? If it's 90, then we know, look at our theorem, if it's 90 degrees, then that piece is equal to that piece, right?
Yes.
So I know that this piece is equal to this piece. So I can say 5x minus 6 is equal to 2x plus 9. Okay? And I'm just going to solve. So minus 2x minus 2x. Boys? I got a 3x minus 3. 3x minus 6 is equal to 9. Plus 6 plus 6. 3x equals 15. Divide. X is 5. And that's all you needed on that was just to find the value of x. Okay? Here comes the hard one, but we can do it. Thumbs up on the last one. Okay? Okay? Here comes the hard one.
You need me?
Just go down to Murphy's for like 5 minutes.
Okay,
You good?
I guess.
Okay.
Okay. All right, here's the hard one. It says find the, watch, radius. Are you looking? I don't see the radius. I'm going to have to draw the radius. In fact, the radius is probably, I'm going to draw right there. Okay? Okay, I drew the radius in. I drew it from the center to point A. Okay? I did that because I made a right triangle. See the right triangle? If by doing a right triangle, I might be able to use Pythagoras Theorem. Okay. So I'm thinking if I draw it in, I'll make a right triangle. In fact, let me highlight the right triangle. I've got this little mini right triangle right here. And I'm going to use that information to help me out, okay? So first of all, I know this, that the two chords are indeed equidistant to the center. So if two chords are equidistant to the center, then the two chords are equal. So I'm going to use this theorem. So I'm going to say, all right, I can do that. This chord, if AD is congruent to BC, right, then I can say, sure, 4x plus 4 equals 6x minus 6. And then to solve it, solve for x, minus 4x minus 4x. 4 is equal to 2x minus 6. Plus 6 plus 6. 10 is equal to 2x. Divide by 2, divide by 2, x is 5. Okay, well, I haven't found the radius yet. I got x, but I haven't found the radius. Great. But that's going to help me get the radius, okay? So x is 5. Let's see. Why don't I go back and put the 5 back in, okay? So I put the 5 right there. 5 right there. And I'll have 4 times 5 plus 4, which is 20 plus 4 is 24. Okay, so what do I have? Well, let's see. I have this length right here. AD is 24. 24. AD is 24. Okay, watch. That means this is 12 and this is 12. So AD equals 24. Okay? AD equals 24. So if the whole thing's 24, then that's 12 and 12, right? So now, I'm looking at this triangle here. Do you see this little miniature triangle in the middle? Let me superimpose that, okay? So I take my little miniature triangle now and superimpose it. Okay? This is 5, and this is 12, and this is my radius. Okay, I just superimpose my triangle. Here it is. Now, from here, how about we use Pythagoras Theorem to get it? Okay? So, how about 5 squared plus 12 squared equals r squared. C squared, r squared, right? 25 plus 144 equals r squared, right? 169 equals r squared. Square root, the radius is 13. And that's what we wanted, was the radius. Now that was a little bit hard of a problem, wasn't it? Okay. So, now, we stop recording.